Hello and welcome to this episode of Between Two Nerds, where we invite a small human being to come and sit between us and have a little chat about science. And this week's small human being is...
Layla, 11.
11 years old. Cool.
Perfect.
And you know they're nerds. I'm Mo.
And I'm Eugene.
Okay, take it away, Layla.
So my first question is, what is the Earth's core made of?
Okay, great question. So,
Cheese. Is it cheese or is that the moon?
So, short answer is it's mostly iron. And a few other metals in there.
Okay.
Nickel and cobalt, I think.
Yeah.
Yeah. So it's mostly iron. Now, the more interesting answer, or the longer version of that answer is that, well, no one's actually been to the core, obviously.
Yet.
So how do you think they found that out?
Tests from...
Okay, yeah. All right, so... first of all, we can, even without knowing, without measuring how heavy the Earth is, we can find out how heavy it is just by how much gravity it has in the first place.
Okay.
So now that we know how much gravity it has, then we can figure out where all of that weight is. And the crust, the bit that we live on, right, isn't particularly dense. You know what the word dense means? Yeah?
Nothing to do with me.
Okay, so dense is how it's mass divided by volume.
Okay.
So how much stuff is squeezed into something.
Okay.
Now that we know, because we know how dense roughly the crust is, we saw that there must be a lot more mass there, and it all has to be concentrated deep inside the core of the Earth. So it's not in the crust, not in the mantle, right? So most of it's in the core, and it has to be something very, very dense that's inside it. Now, to be honest, scientists have just kind of assumed that it's mostly iron. There are some really good reasons why. So there's evidence to back that up. One of the reasons is because iron is like the is in the top 10 most common elements in the universe. Okay. And there's not that much iron actually at the crust, like the stuff that we can like dig around and try to look for it.
Yeah.
So they realize that most of it must be deep in that core. And that would make sense because it's so dense. So that would add to the density of the overall. So it just makes the math of the mass make sense. But no one really knows.
Yeah, okay.
It could be cheese for all we know, but I highly, highly doubt it.
Yeah.
A very dense cheese. A hard cheese, I'm guessing. Maybe Parmesan.
Yeah, Parmesan, yeah.
My dad said that he thinks that it's what's inside of a Malteser.
That would be nicer.
Well, that's not so dense. That's full of bubbles.
Yeah.
So you can tell him scientifically speaking.
It's not.
It's a good guess, but I think it's more likely to be a Parmesan.
Yeah.
So it is still, science is actually still working on trying to figure out, to refine this picture of what's deep inside.
Okay.
And we won't really know completely until we actually start digging in.
Yeah.
I wouldn't want to go there.
No.
Oh, God. Yeah, it's incredibly hot.
Yeah.
I think it's actually hotter than the surface of the sun.
Don't look at me.
Okay, sorry. I get some verification there. I read this somewhere once. I haven't fact checked that. But I think that's the surface of the sun.
The surface of the sun is going to be
but
hot.
then even the I know that's why it's an amazing fact to know. So I think it's hotter, but even the surface of the sun's hot.
Yeah.
But outside in the corona, that's even hotter than the surface of the sun.
Then why, when we put our hands on the ground, is it not hot?
Okay, well, I'm sure this would link to Layla's next question.
Why are there so many layers of the Earth?
Right. Yeah, so many. There's only 4.
Oh.
Right? Yeah, so there's 4 layers. The one that we live on, the top most layer is... Do you know what it's called? No? The crust.
Oh, yeah.
Right?
Okay.
Then just below the crust, we have the next one, with all the lava. The lava place. Mantle.
Okay.
Okay. Then we have the inner core and then the outer core.
Okay.
Okay. So let's start from this. So we'll start from this. So when the Earth was formed, first 4.5 billion years ago, right? So it must be mostly iron and then other rocky materials called silicates and magnesium silicates. Now so first it was just a big molten ball of stuff, right? Floating around or in orbit around the sun.
Yeah.
And slowly stuff started to cool down.
Okay.
But as it was cooling, so it's a liquid. Now on liquids, have you ever done that thing where you've put oil and trying to mix oil and water together?
Yeah.
Yeah. Do they mix?
No.
No, they don't. Which one? They form two layers. Which one's on top?
Normally the oil.
Yeah, normally the oil.
You've been challenged here. I've noticed.
Yeah, normally the oil, right? So the oil is on top because it's less dense, and more dense water is at the bottom. Or if you added like some dish soap to it, the dish soap, which is more dense than the water, would actually sink even lower. Okay? So the same thing happened now because we have this big molten ball of rock and iron and everything floating in space. So the heavier stuff, the more dense stuff starts to sink, which was the iron and the other metals like nickel and cobalt starts to sink, leaving behind mostly rock on the up top. And because it's so deep inside, there's all this friction going on with all these particles moving across each other. So there's lots of heat in the center of the Earth. But the bits that are, so now we have, let's say we have two places. So we have a metal core and rock, molten rock on the outside. Now the rock that's exposed to space will start to cool down and form crust. You know, like when you have a Sunday roast, you got your gravy, you let your gravy sit for a while. I'm very hungry. So you get that little skin that forms on top of the gravy, right? All the fat congeals on top to make it less appetizing, right? Yeah. That's because it's colder. The air above is cooling down that gravy at the top, so we get that little crust. In the same way, you form a rocky crust that we live on. Thank God for that, right? But the rock underneath is still molten because of the heat coming off of the core.
Okay.
And that keeps it molten, and that's why we have lava just below our feet.
Okay.
Magma.
Yeah. And the cores, though, now there's two cores divided up into two sections, inner and outer core, made from the same stuff, but the outer core is liquid.
Okay.
Which would make sense because if you get iron and you metal hot enough, it will turn into a liquid, right?
Yeah.
So, but the inner core is a solid.
Okay.
But it's the hottest part. So, inner core, outer core, right?
The magma.
Mantle, which is filled with magma.
Yeah.
And then we got the crust.
Okay.
That's our bit.
Yeah.
It's the bit we walk on.
Yeah.
Yeah.
That is not hot.
That I still think should be
It's
hotter
not
than it
hot.
is.
Yeah.
Well, if it's as hot as the sun.
I guess if you keep dig
low enough.
It gets hotter. I've heard.
I've never dug that deep. Small hole on a beach.
Yeah.
So then my next question is, why is gravity different on each planet?
It's a good question. Do you have any ideas?
Because it's the length away from the sun.
No, but I like it as an idea.
Well, it feels less gravitational pull the further you are away from the sun. But what that will affect is the speed of our orbits.
Okay.
So gravity is, you create gravity, which is a bit weird because you're not as big as a planet, are you?
No.
And I create gravity. I'm closer to the size of a planet, but I'm not as big as a planet.
Yeah.
So the bigger something is, the more mass something has, the more gravity it creates.
Okay.
So take something the size of our planet, planet Earth. We've got, let's say we're level 1 for gravity. So 1 piece of gravity if you're on planet Earth. So if I jump up, I get pulled back down.
Yeah.
Now, as the moon, if you go to the moon, Do you think that's bigger than the Earth or smaller than the Earth?
I think it would be smaller.
Yeah, it is smaller than the Earth. Top did you know fact. Is it the moon? I think Australia. Do you know Australia?
Mm-hmm.
I think Australia is wider than the moon. Is that right?
Yeah, it's just wider than the moon.
So the moon isn't very big. So it has less mass than planet Earth.
Okay.
Do you think that means it's got more gravity or less gravity?
Probably less.
Probably
No.
less.
Yeah.
You're absolutely right. It has less gravity. I can see Mo leaning in. Are you looking to interject?
No, that's less.
So it's got less gravity because it's got less mass. So
Okay.
if we're going to get super technical, it's to do with that mass, the curvature of space-time.
Okay.
But for that, I think we'd probably have a slightly separate discussion.
Yeah.
But in terms of why you get different levels of gravity on different planets, it's all to do with the size. Well, it's more specifically the mass of that planet. So
Okay.
it's the size and the mass of those objects. But
Okay.
Mo produces gravity and ant creates gravity.
Yep.
Now it's infinitesimal, but anything with mass creates a gravitational field for
Okay.
a small one.
Okay.
Makes sense?
Everything has gravity.
Mm-hmm. Yeah.
As long as you're mass, you've got gravity. That's what Isaac Newton figured out. You know Isaac
Yeah.
Newton? Yeah.
The apple fell.
The apple fell.
The apple
That's the story. Right, yeah. So that's what he would figure out in his law of gravity. And he said everything has gravity. Just the heavier you are, the more of an effect. Gravity is actually a very, very weak force compared to the other ones.
Yeah.
And for there to be for you to be able to feel the gravitational pull of something, you have to be as big as a celestial object.
Okay.
So that's why I'm not being pulled into you right now.
Yeah.
Right?
Okay.
Or you're both being pulled into me, more likely.
Yeah, so he'd have more gravity than me, and I'd have more gravity than you.
Okay.
Yeah.
Yeah. So you said that gravity is one of the weakest forces. So what would be the strongest one?
Good question. So there's four, when you say the weakest force, so there's four fundamental forces in the universe. Okay? When you say fundamental, like basic forces, any other force you can think of, like, I don't know, pressure and all of this, or friction, they're all part of one of these forces.
Yeah.
Most likely electromagnetism. But anyway, so there's, starting from the weakest, we've got gravity.
Okay.
The weakest, I mean, unbelievably weak compared to the other ones. Then we have the electromagnetic force.
Okay, yeah.
Now, which is much, much stronger than gravity.
Okay.
And you can see that, on your fridge, right? You can stop something from falling just by getting a tiny little magnet and sticking it onto the fridge.
Yeah.
That tiny little magnet has enough magnetic force to overcome the entire Earth, pulling it, that says your grade card or something, right? Stopping the Earth and pulling that down to the ground.
Okay.
Then, after electromagnetism, you have the nuclear weak force, right?
Okay.
Nuclear means to do with like the center of an atom. So the nucleus, right? That's where nuclear bombs.
Yeah.
Right, so the nuclear weak force. And then you got the nuclear strong force.
Okay.
So nuclear weak force is what's like a nuclear bomb, right? Nuclear strong force is the thing that powers the sun.
Okay, so there's two nuclear forces.
Yeah.
One's weaker, one's stronger.
One's weak, yeah. They're still both very, very strong.
Okay.
Compared to gravity. But the special thing about gravity is that all those other forces, you only have an effect when you're very, very close to the object. So like for a magnet, for most magnets, like you have to get the magnets quite close together for you to be able to feel the force from that magnet, right?
Okay. Yeah.
But gravity, although very weak, we're feeling the gravitational force from the sun right now because it's keeping us in orbit, right? So it might be very weak, but it stretches along greater distances.
Yeah.
Well, how far is the sun? About 100 million miles?
How far away?
Yeah.
8 light minutes?
There we go. 8.5 light minutes.
Oh, sorry.
Yeah, so
93 million kilometers, I think.
Yeah,
Okay.
that is it. Yeah. It's just
Which is
rounding up.
about 8.5 light minutes.
Yeah, but gravity is actually it is a bit of a mystery as to why it's so weak, because it's so unbelievably weak than the other forces, which doesn't make sense. And scientists think that's maybe because gravity, actually, if there are extra dimensions, right? So you know the 3D, right?
Yeah.
You can move forwards, backwards, right, left, up, down.
Yeah.
Those are your 3 dimensions of space.
Okay.
But physicists who study this kind of stuff believe that there are more dimensions out there. Oh, there's also one more time, but some more dimensions, and gravity might be weak because it extends into all those other dimensions that we do not.
Okay.
We have no way of ever experiencing.
Okay.
So
Makes perfect sense.
yeah,
An infinite number of dimensions.
yeah. We'll leave it there.
Yeah.
That's a whole other conversation.
Yeah.
So did you enjoy that, Layla?
Yes.
Yeah?
Very much.
Thank you so much.
Thank you
Great
very
question.
much.
Thank you for
All right.
having me.
Yeah, it was a pleasure. And thank you guys for listening.
Or
Bye.
watching.
Or watching. Bye. I just
Adios.
nose bumped my mic as well.
Yeah, we'll work on the end.